Hey everybody, Cameron Graham here. Welcome back to another educational series video. Today I wanted to chat a little bit about HVAC and the usages of it, purposes of it, and some ins and outs of some of the more complex installations that we see on some projects. So HVAC itself, funny enough, I was at there was a trivia night recently, and one of the questions was, what does HVAC stand for? So heating, ventilation, and air conditioning, HVAC, commonly referred to. HVAC is obviously the aspect of tempering the air for a occupiable space. So essentially tempering the air to a decent temperature for everyone to work or live inside of, right? So if you think about your house, typical houses have a furnace. You turn your thermostat up or down, the furnace kicks on when the thermostat tells it to. It pumps hot air into your house, and it gets too hot, thermostat says shut her down and stops it. Easy breezy. Some people have AC, those of you lucky enough, and that has the ability to obviously also cool your house. So if thermostat says cool, AC kicks on, pumps cool air in your house. On the commercial side, it is typically kind of the same principle, obviously. Tempering the air for different spaces. Obviously, a larger commercial space has a larger system. In most commercial spaces, we're seeing what's called RTUs, which stands for rooftop unit. So a rooftop unit is essentially a large furnace AC unit up on the roof of a building. There's an opening in the roof for the ductwork to come down and then distribute it out to the different rooms or offices, lunchroom areas, even warehouse spaces per se. And so with that RTU or with that rooftop unit, you're getting the heating, cooling through the supply duct, but then you're also getting return. And I think one of the biggest things that a lot of people don't really talk about or understand is the pressurization potentially of a room, office, area or space, and the need for that return air. So think about it if you have a room in your house. So you have your bedroom, an office area, it's got an exterior window. If the window's closed, you can close the door, not a big deal, it doesn't slam shut, it just kind of closes when you pull it. If you have a window open, you have low pressurization in that room. And so when you go to close the door, it closes very easily. Sometimes it closes on itself. And that is because your room is not pressurized. And so in the commercial buildings and even in your house as well, we need to have pressurization, equalization in the different areas. So the exhaust aspect is a big piece to the puzzle when talking about the HVAC system. Some might say, how does the air get out of this room, or where does it go? How does it get out there? So a few different ways that that's done. Majority of our projects utilize T-bar. Most commercial spaces, T-bar office ceilings. And so then above the T-bar is what we call the plenum space. And so within the T-bar, you might see in some of your offices at work while you're watching this, or if you go visit someone, you'll see in each room, you'll have a little grill kind of piece. Varies in size, usually about 16 to 18 inches by the 2-foot width of the T-bar grid. That allows for air transfer from the room up into the plenum space. So then that plenum space essentially collects all of that, or naturally collects all of that air after the new air is being forced in. Old air goes out and up and then goes into the plenum space, makes its way over to where the exhaust duct is, and then the exhaust duct will suck it up into it. In some areas, in some different projects that we do, and some projects that are all over the Lower Mainland and the world, there are necessities and requirements for full height walls in offices. So we think about bathrooms. You want to make sure that's fully insulated and full height. Some executive offices, lunchrooms, things like that, they have full height walls. So full height means that wall that makes up that office, boardroom, lunchroom goes all the way to the underside of the structure above. So if it's got a mezzanine or a second floor above, those walls go all the way up. If you build those walls all the way up, you insulate them all the way up, you drywall them all the way up, there's nowhere for that air to go above the T-bar in that plenum space. And so in certain circumstances, we will what's called undercut a door. And so there'll be a note on the mechanical drawings showing, stating undercut door. That just means you take off an inch, inch and a half of the bottom of the door to allow for some air transfer that way into the main space. More frequently and typically we see like a grill or an opening in the wall, typically above the door, above the T-bar in the plenum space, for that air to transfer out of the room plenum space and into the main area plenum space where the exhaust duct is, for the RTU to bring it back out into the atmosphere. When it comes to supply, so the ductwork, I always enjoy this. It's like a little map of where the air goes, but essentially you have, RTU or HVAC device or unit that pumps air. You have it ducted. So typically you'll see the biggest duct of an HVAC system will be coming right off the RTU. That's the biggest piece of round, that's the biggest piece of square duct, whatever it is. You'll see the biggest piece is the main branch or the main distribution. And then from there, it typically will branch off to offices, boardrooms, things like that. Each of those rooms is designed, the supply of air to those rooms is designed by a mechanical consultant or mechanical engineer. And they do analyses on how much air is required to temper that room. So you have a large boardroom, you might need 2 or 3 diffusers to ensure that the air is tempered properly in that room. Smaller office, maybe 1 diffuser. That all goes into play with the size of the ducts. So big duct coming off, you might have a little duct that goes into a washroom. You might have a little duct that goes into an office. You might have a bigger size, 16 or 18 inch duct that goes into a boardroom. All depending on the size of that room and also the requirement for that tempered air. When you get into those rooms, you have what's called a diffuser. So if you're in a hard ceiling like we are here, or you're in a T-bar ceiling, you will see what's called a diffuser. And it's basically, in the T-bar, it usually has little fins on it that allow for, that's what they connect to the ductwork, allows the air to come down. Each one of those is dictated on how much airflow comes out of it. There are little dampers built in that during the commissioning of the HVAC system and before the closeout of a project, all of those diffusers, every single one of them, is balanced. And so what we say by balanced is that basically there's companies out there that have a giant plastic bag. It's more complex than this, don't lie, I won't lie to you. But large plastic bag goes over the diffuser and it actually measures the airflow coming out of that diffuser. They will then adjust the damper to ensure that the proper airflow that's spec'd on the drawings is coming out of that. If this is not done, then sometimes you will get a room that potentially is getting too much air or too much hot air, too much cold air, and other rooms are not getting serviced as well as the other rooms. I explain this as I have a laundry room at home and it is the register in the floor is the first register after my furnace. If I don't close that damper almost fully way shut, that room becomes the hottest place in my house. And the rest of my house doesn't really get any air because all of that air is dumping into that one room because it's the first off the bat and the damper isn't shut. So very big piece to it is the balancing and the commissioning of those systems and ensuring that there's a design done and we're following that design and it's getting put in place. So we talked about units, and so there's RTUs, which are rooftop units. There's also another commonly utilized system, and they're referred to as fan coils. So fan coils are units, essentially rooftop unit fans, heating and cooling, but they live within that plenum space, as we talked about. So you think about a large warehouse, maybe with an office underneath. If you put RTUs on the roof, you have to duct it, hard duct all of that air down inside the warehouse and over to the office building. If it's too far, maybe it's not economical to have a large enough unit to push that air that far. That's when you get into a fan coil situation. So the fan coils sit in the space, less duct work, a little bit more economical from a usability standpoint, but you do still have to put a heat pump or some sort of heat pump unit up on the roof. From the heat pump to the fan coil, typically 2 line sets, refrigerant line sets that come down. and those power and regulate the fan coil for the heating and the cooling. So those are the two top ways to manage it. When you get into a little bit more complex situations, and I won't go too far into detail on this, but a lot of times we see an office that has CEO's got an all glass corner office, but then there's the same RTU or the same rooftop unit or fan coil is also servicing, let's say, maybe 2 or 3 other offices within the vicinity of the main office area. Those main offices in the main area are not going to get as hot in the summer months as the fishbowl CEO office because of the sun shining through the glass and all that kind of stuff. So sometimes we get into an instance where they want 2 different temperatures, but it's still running off one unit. And so that's when we get into a little more of the complexity of the VAV boxes, dump boxes, things like that. So there's ways to essentially heat and cool the air after it leaves the main RTU unit and splits off. So you can essentially have one RTU pushing the air down, creating tempered air coming in, and then you can have subsequent mini, let's say, inline duct heaters or inline duct coolers that are connected to their own thermostats to be able to temper the air specifically for one area or another. We're seeing that a little bit more lately when we really get into complex designs for offices. People having specific requirements and needs and wants, and they really want a robust system. You can really put some interesting and fun things into play for that regard. So that's about it for HVAC. I could go on for hours, but that's basically where it all boils down to. And I hope you enjoyed it. Drop any comments or any questions, concerns. Love to answer anybody's questions if they have them. And thanks so much for listening. We'll catch you on the next one. Cheers.